Chapter 2, Kinetic Factors, Class Life Sciences. Part 2, Influence of the Variation in Temperature. At the end of this session, students should be able to identify the effect of variation in temperature on the rate of the reaction. Study of the reaction between H2O2 and I- in acidic medium at different temperatures, starting from the same initial concentration of reactants. Procedure. Consider the following solutions. S1 potassium iodide solution K++ I- of concentration C1 equals 0.4 mol per liter. S2 acidified hydrogen peroxide solution H2O2 of concentration C2 equals 0.06 mol per liter. That means H2SO4 is added to the H2O2 solution. Use 3 beakers. Beaker A contains ice water, that means temperature close to 0. Beaker B contains tap water, that means temperature equal close to 20 degrees. And beaker C contains hot water, T equal 50 degrees. Put in each beaker 2 test tubes. In one containing 10 milliliters of solution S2, that means 10 milliliters of acidified H2O2 solution, and the other containing 5 milliliters of solution 1 containing Ki solution. Let each tube in the beaker for a few minutes to take the temperature of the beaker, the reactants to take the temperature of the beaker. At the same instant, add the content of test tube containing Ki, that means the 5 milliliter, into the test tube containing the H2O2 solution, the 10 milliliter. And start the chronometer at the instant of the addition. Observations. The color in each beaker changes progressively from colorless to yellow, then to red-brown due to the slow formation of iodine I2. For the same interval of time, the darkness of the color in tube A less than that in tube B, less than that in tube C, as it is shown in this picture. The darkness of the color in tube A less than that in B, less than that in C, for the same interval of time. This video shows this experiment. We have 3 beakers. Each beaker contains 2 test tubes containing the reactant. In beaker 1, we have ice water, that means temperature close to 0. In beaker 2, tap water concentration close to 22. And in beaker 3, hot water temperature close to 70 degrees. Tube 1 containing I-, tube 2 containing H2O2, H+, acidified H2O2, each tube containing a solution, a reactant. Now at the same instant, we mix the 2 reactants, or the reactants, at the same instant. Then we put each tube in the beaker. We observe the formation of dark color, red-brown color in tube 3 at temperature 70 degrees, yellow in tap water, and now we observe a yellow color in tube A. After some time, the intensity of color in tube A less than that in tube B, less than that in tube C. The intensity of color increases with time. Now the shape of curve for each experiment, X is the number of mole of I2, X max is number of mole at end of the reaction. In warm water at T equals 20 degrees, this is the shape of the curve. At T equals 0 in cold water, the curve is below the dot at 20 degrees. And for hot water at T equals 70 degrees, the curve is above that of at 20 degrees. Interpretation. Relation between the intensity of color and the concentration of I2. The color of iodine solution changes from yellow to red-brown according to the concentration of I2. When the concentration of I2 increases, the color of solution becomes darker. For the same interval of time, the intensity of color in tube A less than that in tube B less than that in tube C. That means concentration of I2 formed at instant A, T in tube A less than that in tube B less than that in tube C. Effect of the variation in temperature on the rate of the reaction. For the same interval of time, delta T, we found that concentration of I2 in tube A less than that in tube B less than that in tube C. And since the rate equal variation of concentration and variation of time, same interval of time, then rate in tube A less than rate of formation of I2 in tube B less than that in tube C. And since temperature in tube A less than that in B less than that in C, we have same initial concentration of reactant, then the concentration or initial concentration of reactant is not a kinetic factor. Therefore, we can conclude that when T increases, the rate of formation of I2 increases and vice versa, then the temperature is a kinetic factor. Conclusion: the temperature is a kinetic factor. When the temperature increases, the rate of the reaction increases, and when the temperature decreases, the rate of the reaction decreases. That means vice versa. Application 1. In acidic medium, thiosulfate ions S2O3 react slowly and completely with hydronium ions H3O+ according to the following equation. S2O3 plus 2H3O+ give S sulfur solid and SO2 plus 3H2O. The two experiments represented in the table below are carried out where delta T represents the end time of the reaction in each experiment. By comparing the two experiments, we have same initial concentration of S2O3 same initial concentration of H3O+, but temperature in experiment 1 bigger than that in experiment 2, so that the rate of the reaction in experiment 1 is bigger than rate of the reaction in experiment 2. The question is compare delta T2 and delta T1. When rate increases for the same initial concentration of limiting reactant, the limiting reactant S2O3 or HO+ is the same at the end of the at the T equals 0. That means the concentration of product or amount of product at the end of the reaction is the same, but when the rate increases, the time decreases. Then delta T1 is less than delta T2. Solution: by comparing experiment 1 to experiment 2, the common is same initial concentration of reactants, but the difference is temperature in experiment 1 bigger than temperature in experiment 2. Then the rate of the reaction in experiment 1 is higher than that in experiment 2, since temperature is a kinetic factor. Then delta T2 is bigger than delta T1, or delta T1 less than delta T2. Now, effect of the variation in temperature on the shape of the curve. Effect of the increase in temperature. If we repeat the same experiment with one modification, we increase the temperature of T prime bigger than T. What is the effect of this variation on the shape of the curve? First, on the shape of the curve, concentration product equal Ft. Explanation. T is a kinetic factor. When T increases, the rate of formation of product increases. That means at each instant, concentration of product in experiment 2 bigger than concentration of product in experiment 1. But since the reaction is complete and the limiting reactant does not change, then the maximum limit of the curve, which is the concentration of product at infinity, does not vary. Therefore, the curve concentration product equal GT is over the curve concentration product equal FT. Graphically, this is the first curve, concentration product equal FT at temperature T. This is the maximum limit, concentration product at infinity. The new curve at T prime is above the old one, but less than the maximum limit, below the maximum limit. Now, on the shape of the curve, concentration reactant equal Ft. T is a kinetic factor. When T increases, the rate of disappearance of a reactant increases. At each instant T, concentration of reactant in experiment 2 less than concentration of reactant in experiment 1. Since the rate increases, then the concentration of reactant disappeared increases. That means the concentration of reactant left decreases. The curve concentration reactant equal GT is below the curve concentration reactant equal FT on the graph. This is the curve at T. At T prime, the new curve is below the old one. Effect of the decrease in temperature. If we repeat the same experiment with one modification, we decrease the temperature. T prime less than T. What is the effect of this variation on the shape of the curve? First, curve of formation of product. T is a kinetic factor. When T decreases, the rate of formation of a product decreases. That means at each instant, concentration of product in experiment 2 less than that in experiment 1. The curve concentration product equal GT, the new curve, is below the old one on the graph. This is the old one, then new curve is below it. And on the shape of the curve, concentration reactant equal Ft. T is kinetic factor. When T decreases, the rate of disappearance of reactant decreases. Then at each instant T, concentration reactant in experiment 2 bigger than concentration of reactant in experiment 1, because when rate decreases, the concentration of reactant decreases, then the concentration of reactant left increases. The curve concentration reactant equal GT is over the curve concentration reactant equal FT on the graph. This is the old curve at T. The new curve at T prime is over it. Application 2. Consider the reaction CH3T times Cl plus 2H2O gives CH3T times OH plus H3O plus Cl minus. The result of the kinetic follow-up of the reaction are given in the following table. Part 1. Plot the curve representing the variation of the concentration of CH3T times Cl as function of time in the interval of time 0, 90 minutes. We are given the scale. Part 2. The same experiment is repeated, but with only one modification. The reacting mixture is maintained at a temperature T prime greater than T. Trace on the same graph of part 1 the shape of the curve concentration reactant equal GT in the interval of time 0, 90 minutes. Justify. Solution. This is the curve concentration RCl equal Ft. 2. Since the temperature is a kinetic factor, so when T increases, the rate of disappearance of CH3T times Cl increases. Then at each instant, concentration CH3T times Cl in experiment 2 less than that in experiment 1, because the rate increases. Then concentration disappeared increases, concentration left decreases. Therefore, the curve concentration CH3 times Cl equal GT must be below that of concentration reactant equal Ft. On the graph, the blue one is the old one at T. The new one at T prime is below it. Application 3, the equation of the composition of hydrogen peroxide is H2O2 give H2O plus half O2. To follow up the kinetic of this reaction, we titrate the amount of hydrogen peroxide left at different instants, but before starting the titration, icy water is poured into each beaker. Indicate the role of this addition of icy water and specify the two kinetic factors involved in this operation. In chapter 1, we have seen that to stop the reaction, we add icy water, the taken volume in icy water. Then the addition of icy water is to stop any reaction other than the titration reaction. Now, what are the kinetic factors? The addition of distilled water, this is a dilution, decreases the concentration of H2O2, then the rate of the reaction decreases. The kinetic factor affecting the rate of the reaction is the concentration of H2O2. But why we add cold water, icy water? In order to decrease the temperature of the reaction mixture, that decreases the rate of the reaction. Then the kinetic factor affecting the rate of the reaction is the temperature. This is the end of part 2, influence of temperature on the rate of reaction.